Alright, in the previous video, we practiced the fundamental building blocks that will allow us to prove that triangles are congruent. But in this video, we will actually do some proofs, some triangle congruence proofs. So let's start with number 10. So we are given that segment LM is congruent to LO. Those are already marked. And I see that here in the proof. So I can just go ahead and say given for the reason. And we are given that MN is congruent to ON. So MN, ON, those are already marked. Here it is in the proof, so given. All right, that does it for the given. Now, so far that is not enough for us to prove these triangles are congruent. Remember, there are 5 ways to prove triangles are congruent, and that is 3 pairs of sides, or we could have 2 pairs of sides and the angle in between them, or we could have 2 pairs of angles with the side in between them, or we could have 2 pairs of angles with the side that's not between them, or we could have a hypotenuse and a leg of a right triangle. Okay, those are the 5 ways. So this is not enough, but the shared side, LN, is automatically going to be congruent because it's the same side for both triangles. And that is called the reflexive property. When you have that shared side and you're saying that something is congruent to itself, that is called the reflexive property. All right, reflexive property. All right, I'm going to abbreviate. So that makes these triangles congruent. So triangle LMN is congruent to triangle LON by the side-side-side theorem. Okay, because we have 3 pairs of sides. Moving on to problem number 11. Okay, we are given a pair of parallel sides. See these little arrows? That means that these sides are parallel. It does not mean they are congruent. So do not count these when you're thinking like side angle side or something like that. These don't count as S's. However, parallel sides lead to congruent angles. And let me show you how. If you want to see the angles that are going to be congruent because of the parallel sides, start by tracing the parallel sides. So this side and this side are parallel. Now, try to make either an N or a Z out of those sides. Okay, well if I connect them this way, it makes an N. Now the corners of this N are called alternate interior angles. Remember that phrase. All right, these corners are called alternate interior angles. So they are going to be congruent by the alternate interior angle theorem. In fact, we should probably just go ahead and get the proof going. So, of course, we were given that these 2 lines are parallel, so here it is, so we get to say given. But then parallel lines lead to congruent angles. And I just showed you the corners of the N are going to be congruent. So I can say, well, they conveniently put angle 1 and angle 2 here, so I can say angle 1 is congruent to angle 2, and that's called the alternate interior angles theorem. All right, the corners of the N or the Z, those are alternate interior angles, so alternate interior angles theorem. Okay, now next in the proof it says angle R and angle S are right angles. Well, that is something else that is given to us. All right, I'm going to go ahead and erase the N for now. All right, so we have that. They're already marked the right angles, but that was given. Now, when it comes to filling out a proof, saying that 2 angles are right angles is not enough to use those angles as part of an angle side or something like that. These don't count as A's yet. If I want to count these angles as congruent angles, I need to say that they are actually congruent to each other. So sure, they are right angles, that's given. But what I need to say is that they are congruent. So angle R is congruent to angle S. And for the reason we just say right angles are congruent. All right, and I know that seems obvious, but you have to spell it out. Okay, so fine. They're already marked, so I don't have to mark them. Now, the next thing that's not marked is the shared side QT. All right, the shared side will automatically be congruent for both triangles because it's the same thing. So I can just say segment QT is congruent to segment QT. All right, that's how that shows up when you have a shared side. And that's called the reflexive property, when you have that shared side equal to itself. Now, if you look at the picture, that is actually enough information to prove the triangles are congruent. Again, when you're asking yourself whether or not this is side, 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 side angle, side, etc., at this point you should not be looking at these parallel marks. All right, these little arrows have nothing to do with it. You should be looking at these pink, these red angles, and you should be looking at these 90-degree angles, and you should be looking at the shared side. Do not look at the arrows. All right, so then hopefully you see that what we have is we have two angles and a side. The side is not between the angles, so that makes this angle, angle, side. If it had been side QS, for example, QS is between these two, then it would be angle, side, angle. All right, but anyway, that's it for number 11. For problem number 12, we are given that I is the midpoint of GK and HJ. Okay, so if I is the midpoint of GK, so here's GK. So if I is the midpoint, that means GI is going to be congruent to IK. So let's write that down. GI is congruent to IK, segment IK. And yeah, that's the definition of midpoint. All right, if you have a midpoint, then it'll be congruent on either side. Oh, I forgot to just write down given for the reason for this. All right, but we were told that I is the midpoint of another segment, HJ. All right, so if I is the midpoint of HJ, then that means HI is congruent to IJ. So HI, segment HI, is congruent to segment IJ. For the same reason, definition of midpoint. Okay. Next, they already gave us the next statement. Angle GIH, that's this angle, is congruent to angle KIJ. KIJ, that's this angle. Why would those two angles automatically be congruent? It's not given. Because these are vertical angles. And we know that vertical angles are always congruent. Vertical angles are congruent. Or you could have said vertical angles theorem. So that's enough information to prove that these two triangles are congruent. Now, which one of the 5 methods is it? Well, we have two sides and an angle. And the angle is between the two sides. So that makes this side, angle, side. Okay? All right, I'm actually realizing that there's sort of a typo here. We were given all this stuff, but it didn't actually say what we were supposed to prove. So I'm just going to write that in and fix that up. You know, I can tell what we were trying to prove because of this extra statement in the proof. So I'm just going to write that down. So clearly the thing that we were trying to prove must be this right here. So there, I squeezed it in right here. Prove angle G is congruent to angle K. Once you already have the triangles congruent, you can go ahead and say that any other corresponding parts are congruent, because corresponding parts of congruent triangles are congruent. All right? So I just wrote down this CPCTC, and that's, one more time, that stands for corresponding parts of congruent triangles are congruent. All right, so this is not just a matter of memorizing some meaningless words. I want you to stop and think about it. We already proved that the triangles are congruent. So if the overall triangles are congruent, doesn't it make sense that angle G specifically will be congruent to angle K, since those are corresponding parts? All right, G and K are corresponding. So of course they'll be congruent because they're corresponding parts of congruent triangles. And it makes sense that corresponding parts of congruent triangles will always be congruent. So this is what you always put once you already have the triangles congruent and you're asked to prove that an extra pair of parts are congruent. Well, let's do one more. For number 13, we're just given a bunch of parallel lines, okay, and they're all marked. So might as well just go ahead and write given for those. But remember, these arrows do not mean that these sides are congruent to each other. They're just parallel. Parallel lines do not lead to congruent sides. They lead to congruent angles. And to see which angles are congruent, pick a pair of parallel sides. For example, well, you know what, let's go in order. So they first gave us AC is parallel to BD. Trace those. So here's AC and here's BD. All right? Now, see if you can draw an N or a Z out of them. So using the sides I've already traced, if I draw this connector, this transversal, it forms this N shape. Now, the corners of the N are alternate interior angles. And if the lines are parallel, then those will be congruent. So back to the proof, I can now say that angle 1 is congruent to angle 4. And like I said, these are alternate interior angles. So I'm going to zoom in so I can really write this out. So I'm going to say we say alternate interior angles theorem. Do not simply say alternate interior angles are congruent. Don't say that, because alternate interior angles are not always congruent, only when the lines are parallel. So that's the alternate interior angles theorem. All right, next we have another pair of parallel sides, AB and CD. So to find out what angles they will cause to be congruent, start out by tracing those lines. Can you draw an N or a Z out of these? Sure. If I draw my transversal connecting them, that forms this Z shape. I mean, I know it's backwards. the corners of the Z are alternate interior angles. And when you have parallel lines, alternate interior angles are congruent. So these two angles will be congruent. So in other words, angle 2 is congruent to angle 3. And that's going to be the exact same reason as before. These are alternate interior angles of parallel lines. This time I'm going to abbreviate though. So I will say alternate interior angles theorem. All right, that's how you would abbreviate that. Okay, next I see that segment AD is congruent to segment AD. That's the shared side. So when you have a shared side that's going to be equal to itself for both triangles, that's called the reflexive property. All right, the reflexive property. I will abbreviate that. And now that's enough information for us to say that these two triangles are congruent. I see I have two angles and a side. So the question is this going to be angle, angle, side, or angle, side, angle? Both of these involve two angles and a side. Well, it depends on whether the side is between the two angles. If the side is between, then it'll be angle, side, angle. If the side is not between the angles, it'll be angle, angle, side. This side is in fact between the two angles. That's why the triangles are congruent by angle, side, angle. Alright guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.